Hello, Mr. Gazda here. Review 138 for the weathering and groundwater test. Okay. Please, hopefully you read this because this is important. You should go through your notes before doing this. This alone is not the only review you should be doing. Definitely do this. So, let's go through this to check your answers. One should be one because check this out. There are equal sized beakers filled with beads, and basically beaker A and B have the same porosity, so they can hold the same amount of water because well-rounded, well-sorted, well-rounded, well-sorted, even though these are bigger. Size doesn't matter. These are the same porosity. This has less porosity because these smaller particles fit in between the larger ones, and porosity is how much water can be stored in the open spaces. So that's choice one. Question two should be answer one. And similar question, it has well-rounded, well-sorted, smaller, medium, larger size, but they're all the same size, all really rounded. Basically, they all have the same porosity, how much water they can hold. This is one that drives kids crazy and people often get wrong. So in this case, percentage of pore space, 40%. They need to be equal. So basically it's saying 40% of the total volume here is open space, and that's where water will go. Question three is answer one, cross-section below. Which is the greatest resistance to weathering and erosion? It resists weathering the most. Therefore, it has been weathered the least. And that is rock layer A. And you can tell because it sticks out the most. It juts out. All of these have been weathered more than it. So the greatest resistance, that often, the wording there messes kids up often. But that's choice one. Number four, during a rainstorm when soil becomes saturated, the amount of infiltration. You have to know infiltration is water soaking into the ground. And when soil becomes saturated with water, it means it can't hold as much water. The infiltration will decrease and causing runoff to increase. Runoff is water basically staying on the surface and then flowing downhill. So 4 is 2. 5, which processes are most likely to cause a rise in the water table? And that's going to be precipitation, rain or snow, and then infiltration. Water soaking into the ground will be added to the water table. So 5 is choice 2. 6, you make sure you read all of this here because that's very important, and it's reading about the lichens and growing on the bedrock and how they give off acid, and also their roots will break up the rock. So basically, the answer to 6 is 2 because the soil shown in time 2 was formed mainly by weathering, that's the breaking of the rocks by the roots, and biologic activity, which is the lichens growing and again breaking it down by the roots and giving off the acid. So best answer there for 6 is 2. 7 is choice 1. So this is showing caves, really known as caverns, and it basically asks how did these caverns and sinkholes form, and is the bedrock chemically reacted with acidic groundwater. So these types of caves, most caves form in limestone or dolostone, a rock made of minerals that react with the acid and it slowly dissolves it. That's where most of these caves come from. 7 should be answer 1. Number 8, during a rainstorm, water flowing downhill. What will be the effect on the relative amounts of runoff and infiltration when the water reaches an unsaturated soil with gentler slopes? So when the flatter it is, the slower water goes, gives it more time to soak in. Unsaturated means that the soil is pretty dry, so it can hold a lot of water, like a dry sponge basically would be, can hold a lot of water. So the answer here should be the runoff will decrease, okay, because of the gentler slope, and then infiltration will increase. Unsaturated soil, the gentler slope, you have more infiltration. 8 is choice 2. 9 and 10, they deal with this here. Always make sure you read this. I'm saving time, so I'm not doing it. But basically, there's a rock ledge that sticks out like a mini waterfall here. 9 is answer 1. Compared to the rock layers above and below, the characteristic of the rock ledge is greater. It has more resistance to weathering. It resists weathering the most, therefore it kind of has been weathered the least and sticks out. Again, that semantics there can be confusing to people, so make sure you read it carefully, think very carefully, slow yourself down to get those right. 10 should be 4. Rock fragments that are tumbled and carried over long distance by the stream are most likely becoming more rounded, smoother, and smaller. If you think of the rock shaking lab, that's basically what happened. That's called a abrasion as the rocks rub and scrape against each other. It's not really the water that's causing it. It's not the container in our lab. It is them rubbing up against each other and the bedrock itself. 11 is a standalone question, doesn't deal with this. Which conditions on Earth's surface will allow for the greatest amount of water to seep into the ground? And that will be infiltration, water seeping into the ground, gentle slope, and permeable. The more permeable it is, the faster water can go through. Impermeable is something water can't go through. So like this desktop, impermeable. Concrete, impermeable. So that's a key concept there, so that should be 1. 12, which rock weathers most rapidly when exposed to acid rain? Now, a good thing to do would be to use your reference table to look some of this up. And if you were to look them up, acid rain, you have to you should be recognizing now that it's going to be a mineral that reacts with acid. You're looking for calcite, dolomite, and if you look up all these rocks, limestone is the best answer because that is made of calcite that will dissolve in the acid rain. Next up, make sure you read all of this here. It's not the most exciting stuff in the world, but it is important and it deals with this. It's very hard to get any of these right without really understanding this. But 11 is 4. All of the particles in these 4 columns are classified as pebbles. Now, how to do that, you have to see the size here, 0.4 centimeters or in millimeters here. And you have to realize you have to go to the reference table. You don't know this out of your head. And you should go here with the smallest one being 0.4 centimeters and the large one 1.3. So the smallest one's 0.4, so that's larger than the pebbles here. So they're all in this range. They're all pebbles. That would be choice 4, but you need the reference table for that for sure. Number 12. This is one with just the graphs of the answers. Which graph best shows the rate of infiltration of water through the particles in these four columns? So this is permeability, how fast water goes through. Now this is one where the larger particles have more permeability. So these are all the diameters from here to here to here to here. As you go along here, the water rate of infiltration, how fast it goes, will go up. Choice 2 is the answer. Hopefully you remember that from Lab 15, the permeability lab. Larger sediments, the water goes through faster. 13, which column of particles retain the most water? That's after the clamps and the water's been drained. Water retention is the water that stays in the sediments that don't drain out. And this is one of those, know the relationship. The smaller the particles, the more water is going to retain. There's more surface area, the spaces are smaller, and water will get stuck and kind of cling in there. So the answer should be 1, in this case, the smallest particles. 14 and 15 both deal with this. Again, read all of this. Here are our tubes we need to look at. Capillarity will cause water to rise highest in. So this is water in the screen, also like in Lab 15, and the water rising up. Also like the paper towel demonstration you may have seen, water rising up. That's called capillarity or capillary action, and that's one of those things. It is where the smaller the sediment, the higher it will rise. The smaller little spaces will rise highest. In this case, pebbles, large sand, medium sand, large silt. This is the smallest, so its answer is 4, column D. This question here also deals with this. 15 in my version got cut off. Equal volumes of sediments are mixed and poured into a column of water. How will they settle? Now, this is something, we haven't really done this, so this is more of the next unit, but we have it in here. And basically, we'll show this in class, so you will see it if you haven't seen it yet. Pebbles on the bottom, larger sand, medium sand. So you go larger to smaller. Again, this kind of stuff, sediment deposition, is not going to be on this particular test, but it happens to be on this review packet, but that would be answer 3. So don't sweat it too much. We will cover that more next unit. 16 through 19. Here we go. 16 is choice 2, infiltration. Letter F, water soaking into the ground. That's infiltration. Know it. The terms here are important. This unit, as I've said, has a lot of different terms in it. 17, what letter does X represent? It's choice 1. X right here, groundwater. That area is a zone of aeration. It's saturated there. X is the groundwater. Notice how it matches up with the lake level, which it does. So 17 is 1. 18, if the surface soil is saturated and precipitation increases, there will be an increase in the amount of runoff. The soil is saturated. It's kind of full. Like a full sponge, can't hold much more water, so the water's not going to soak into the ground. It's going to stay on the surface and either puddle up or flow downhill, and that's what runoff is. 19. The process of transpiration and evaporation are represented by letters. Well, A is evaporation. Transpiration is the water vapor given off by plants. That's C. That's one thing that the regents in these tests really love is transpiration for some reason. So the answer here is 3, 4, 19. Okay, these are part 2 questions. What I'm going to do for the answers is not really give so much out of my head, but I'm going to use the actual Regents answer key, which I have here, to give you a sense of sort of how we need to grade the Regents exams, and the answers are very clear. So, this shows this diagram here of a stream. Explain why rock particles transported by the stream often become more rounded. So, here, circled here, would be this one. So some of the examples that like the state would give is you could say something like abrasion or friction between the particles, bouncing and rolling along the stream bottom causes it to be more rounded, the particle collisions break off pieces, the particles are weathered. That's kind of a vague one, so I don't love that. And it does say even, do not allow water erosion alone, because transported by the stream is part of the equation. Do not allow rounding by water, because water alone does not produce rounding. So this is really good to see sort of what works and what doesn't work. This is like the official answers here. So I think that's helpful to people. Now, next one here, these 2 questions deal with this diagram. Describe the general relationship between the amount of rainfall and the amount of runoff presented by C. So that's runoff, water flowing over the surface. Let's see what answer they present. So here, so for 21, they say, you could say, as precipitation and rainfall increases, runoff increases. More rain leads to more runoff. There's a direct relationship. You could say that. Runoff is usually less than rainfall. So these are just some of the answers. There could be a lot of other ones that are also right, but that's basically, usually the first one here is really what you want. More precipitation, more runoff. Question number 2, what is the main source of energy for the water cycle? And this one, what's key here is the water cycle really is about evaporation and transpiration. And what's going to cause that is the sun. So here, so the sun, insolation, we haven't used that term yet, incoming solar radiation, that's coming up. Solar radiation, solar energy, sunlight, that is really what causes all of it, and it causes the plants to grow. That's what will basically, bring the water up to higher elevation, cause streams. It's the evaporation and condensation into clouds. So the sun there, solar energy, is the answer to 22. On the next page, the last few, okay? Again, always read all of this. Here's this diagram here. Identify water cycle process A, which produces cloud droplets. Condensation. And that's really, if you look here, this is the answer key too. It says condensation. There's nothing else other than condensation. There's no other words that you can use. That's a pretty just firm answer. 24. Describe the soil permeability and land surface slope that would allow the most infiltration of rainwater and least runoff. Make sure you get those right. Oftentimes kids will get those flipped, and even though they may know it, they'll get the answer wrong. So soil permeability, we're looking for most infiltration, least runoff, and the surface slope. So under soil permeability, you could say high permeability. The soil is unsaturated. The soil allows water to move easily or through it, but very, very permeable soil, things such as that. And then the surface slope for the least runoff, most infiltration, you want gentle slope, you want it to be flat, something like that, a slope that's not very steep, very level. Any of those answers work, or anything that gets that point across. You don't need those exact words. And then the last one here talks about the groundwater seeping through the cracks. Identify one characteristic of limestone that allows this type of weathering to occur. So you want to say mainly type of weathering, is it chemical or physical? You got to write that there. And then one characteristic that allows this weathering to occur. So the type is chemical weathering, you had to write that, and you need to get the second part right as well, which the characteristics of limestone is acid dissolves limestone, the calcite in the limestone chemically reacts with acid, limestone is composed of calcite. Any of those answers work, or anything that gets that point across will also work. So that's just a small idea of some of the sort of test questions you may get. Hopefully you did well, but really, hopefully you spent time studying your notes and going through other work beyond just this, because this is just not enough. But I am Mr. Gazda. I hope that was helpful. Thanks for watching.